Are we ready? Okay, wonderful. So today we're going to talk about factors that impact sound propagation. How could sound change when it goes through medium, or what can affect the sound? So the first thing is a word called refraction. Refraction means the bending of light when it goes from one medium to another. So when light goes from, say, air into water or air into glass, it actually bends. The amount of it bending is called refraction. When it bends from a lighter to a denser medium, it bends toward what we call the normal. So for example, if this is air and this is water, the normal to the surface is drawn in the red line. When a light ray comes in, it actually bends towards the normal. Vice versa, if the same light ray goes from the denser to the lighter medium, it will actually bend away from the normal. So when we were talking about reflection, we said that the angles are measured with respect to the normal. This angle is called incident angle. And this angle is called refracted angle, sometimes also called transmitted angle. Similarly here, this angle will be incident and this angle will be transmitted. Everything is measured with respect to the normal to the surface. Keep these two pictures in mind. 1 and 2. And this phenomenon of waves bending is called refraction. There is an animation. So for example, light bending from air into water will bend or like this. Note where the incident angle is and note where the refracted angle is. Okay, so you can clearly see that theta 1 is bigger than theta 2. So when light moves from one medium to another, some is reflected at the boundary while the other is transmitted. The transmitted light is called the refracted light. The amount of refraction is given by a relationship which is called the Snell's law. And the Snell's law is this. NA sine of theta A equals NB sine of theta B, where theta A is the angle of incidence and theta B is the angle of refraction. N is called the index of refraction. And it is given by this relationship here, where c is the speed of light in a vacuum. And this v is the speed in the medium. So I don't know how many of you have heard that the speed of light is a constant. Yes? And nothing goes faster than the speed of light. I would like you to add 3 or 4 more words to it. Speed of light is a constant in the medium we are looking at. Nothing can go faster than the speed of light in the medium we are looking at. So the 3 times 10 to the 3 times 10 to the 8 meters per second is light traveling in a vacuum. When light travels through air or glass or any other medium, it does not travel 3 times 10 to the 8 meters per second. It actually travels slower. By how much slower depends on the index of refraction of the medium. Got it? Yes? The what? V is the speed of the medium. Let me take this out. V is the speed of light in the medium itself. So C is the speed of light in a vacuum when it has no obstruction in the middle. So for example, light traveling through air will have a different speed. Light traveling through glass will have a different speed. Light traveling through water will have a different speed. Light traveling through murky water will have a different speed. Make sense? And each of these speeds depends on this index of refraction, which has been calculated for us. So we don't have to do them. We find them in a table, we find the value, we put it in, and we're done. Okay? Properties of refractive waves include that refractive waves change directions, the speed, and wavelength. However, the frequency remains the same. For light particularly, if you wanted to remember what value changes, so if you see a red light and you're wearing glasses, does the red light still look red to you? Behind the glasses you wear? It should, right? Because it doesn't change frequency. Colors are related to frequencies. So when frequencies do not change, the color of the light does not change. However, its speed changes, its wavelength changes, and also it bends. So remember that. That's my easy way of remembering. So if somebody asks me what changes when it goes from one medium to another, I think, okay, the color will not change. My red light still looks red. My blue light still looks blue. So, and color is related to frequency. So basically my frequency does not change. Everything else changes. Got it? So write that down. Like frequency will not change because the color of the light will not change. Remember, so far I'm talking about light, but all waves do the same thing. So sound also does the same thing. So the frequency of sound will not change, which would be very funny if that would happen, because think about it. Radio waves, right? Depending on whether you're listening to them in the thunderstorm or whether you're listening to them in a desert or whether you're listening to them in heat or cold, right? They should sound the same. The frequency should not change. Okay. So now let's do an example.
Air and water. The angle is 30 degrees. What is the angle of refraction?
So when you get a question like this, first of all, you should write down what is given. NA is 1, NB, N water, is 1.33, and theta incidence is 30 degrees. And they're asking me for refracted angle. So what law should I use? Called the Snell's law. NA sine of theta A equals NB sine of theta B. In this case, the B is just water. So what are they asking me for? That I know this is 1. I know this is 30 degrees. I know this is given as 1.33, and then sine of theta W. I'm going to plug values back in. So I will have sine of 30 degrees divided by 1.33 equals sine of that equals sine of theta W. So how do I find theta W from here? Sine inverse of 0.38. How do I find sine inverse? On your calculator, do you see a sign -1 on top of that button? Usually it's the second like the, or inverse, I don't know what calculator, yes? 22 degrees. Woohoo! Sometimes the question will give you both thetas and ask you for one of the angle, so one of the refractive indices. So like it could give you any combinations of stuff and you just have to find the other things. Good?